I'm just going to see what screens are.
All right, so it looks like we've got attendees coming in. So we're going to give this 20 to 30 seconds for everybody to get into the meeting, and then we'll go ahead and get started. It looks like everybody is in, so we'll go ahead and get started. Usually I say one, but we're doing a 4 o'clock webinar for this one, so I will say good afternoon to everybody, and welcome to WITMIX's webinar, Connecting the Dots, Intraoral Scanning and 3D Printing, and I'm joined by the one and only Dr. Charlie Wahl. It's a pleasure to have you, sir. My name is Bryce Hiller. I'm a digital marketing specialist here at WITMIX, and I'm going to be facilitating today's webinar. I want to begin with just a couple housekeeping items. First, in the upper right-hand corner of your screen, there you should see a questions box up there. Feel free at any point during the webinar to type in a question. I'll be monitoring those and asking them or bring those questions over to Dr. Wahl accordingly. So feel free to utilize that. We will answer to the best of our ability every question that does come in. Next, if you're a CDT, this webinar is approved for 1 hour of CE credit toward your certification. Within 1 to 2 days, roughly, you'll get an email that you use when you registered and it'll explain how to get your CE credit. And finally, this webinar is being recorded, so within 40 hours, it will be up on our website at witmix.com in the webinar section, and we are also actually streaming this live to Facebook, so it will also be on our Facebook page, and then eventually it will also be on our YouTube channel as well. So now what I'd like to do is go ahead and introduce our guest today, which is Dr. Charlie Wahl. Dr. Wahl received his undergraduate degree in biology from Rowan University in Glassboro, New Jersey, and his DMD from Temple University in Philadelphia. After graduating from Temple, he practiced as an associate on the island of Guam for 4 years, working in both a clinic and private practice environment. In 2000, he moved to New Jersey to work as an associate, and then in 2003 became the practice owner. Wahl completed training at the Dawson Academy for Advanced Dental Studies, where he is an ambassador. He also completed his training at Spear Education and digital training in the E4D complete curriculum. As a digital dentist, Dr. Wahl was trained in advanced 3D design at Sculpture Studios in 2019 and is a Cranham Culp Digital Dental Design Training member. He currently practices and lives in Hollingswood, New Jersey with his wife Bridget and their 2 children, Wolfgang and Lucy. And that's all I've got. So with that, Dr. Wahl, like I said, it is an absolute pleasure to see you again and to have you on our webinar today. So let's go ahead and start it.
Hi, everybody. Just getting things up and rolling. So first of all, I want to say good afternoon. Happy Tuesday. The work week's kind of almost halfway done. And so I hope everybody's had a good week so far. So connecting the dots between scanning and printing, it's kind of a topic that goes undiscussed, I think, and kind of has some misunderstandings in the process. And so WITMIX, we were talking and we kind of wanted to hopefully kind of solve some of the information or lack of information on how do we go from this cool intraoral scan to actually getting a printed 3D model. Bryce kind of covered most of this stuff. I kind of entered the digital world like most dentists in the mid 2000s, where I got into in-office milling, same-day crowns, those kind of things, and it was great. It was a welcome introduction to a new way to practice. But after about 5 years, you kind of felt limited on the materials that we had. You started to realize that there were some accuracy issues that, the lab quality milling and finishing of digital products was just way nicer than we could accomplish in office. And so I started trying to figure out what can I do next. And with the help of Whitmix and one of my mentors, who's a prosthodontist in Cincinnati, we kind of talked about what's the next phase for digital dentistry, and we kind of got into a discussion about, hey, what about having some kind of dental lab that will manage all of this for you? And so that's when I kind of made the jump, which was, towards the end of 2017, and we started to look at, hey, what can we do differently than what we're doing now? And back then it was kind of a, figure it out on your own, with the exception of Whitmix, their technical support. Bryce and I were just talking a little bit ago of how it was just the best training ever, on the job training in some ways, and their customer service was great through that process as well. And back then you just, there weren't a lot of resources, you had to kind of pick and choose. You spent a lot of time on YouTube, and but then 3Shape kind of had their academy. Ivoclar was another great source. But nowadays it's just so much easier. And, thanks to John Cranham and Lee Culp, they just started this digital dental group, and it's really simplified the learning process. I'm really happy to be, a little tiny part of that process, and the ability that they have now to kind of help all of us, efficiently figure digital dentistry out, to efficiently kind of learn the steps that are involved, really just make a lot of sense. And the format has just been great. So thanks to them, I think this process will become a lot easier for everybody. Things we do in our lab, we pretty much do everything, all materials, or pretty much all materials out there, we do in some format, whether we mill or print, pretty much everything in dentistry. It's been a pretty cool process learning the software, but even more so playing with materials. So topics for today, how do we get from that scan to print? It involves quite a few things. They don't need to be overwhelming things, but there are certain steps. I remember Pete Dawson always saying, the longest distance between 2 points is a shortcut, and it's a learned experience, I believe. And it doesn't matter whether it's in regular dental world or the digital world, steps are there for a purpose, and it just makes sense to follow a workflow. So we'll talk about scanners. We'll talk about the software that controls all of these different platforms, different hardwares that we need. We'll talk about how to build models, different 3D printers, the types of resins we can use in dentistry, and then some of the other finishing touches that are required once we get a digital model made. So, this whole webinar started with, how can we clear up some misconceptions of going from a scan to a model? There's talking to dentists who are interested in digital dentistry that haven't made the jump yet. I'm talking to some dentists who have decided to purchase things, but maybe really haven't had all of the information put in front of them. A lot of folks think that, hey, once I scan this patient, my models are pretty much ready to go. And the reality is, it doesn't take much to get to a digital model, but there are those steps that we have to follow. It's not just as easy as scan, print, and do whatever we were going to do with our restoration or with our digital object. So hopefully today we'll be able to answer the question of, how do we do this? How do we go through this process? And how do we try to do it as efficiently as possible? Because technology is great, but if we're not efficient, it just isn't successful. So some basic requirements for going from scan to build to printed object. We have to have a scanner. We have to have some software to help us with our model building. And there are starting to be some overlaps with some of the scanners. We'll talk a little bit about that in a few minutes. But then we also need a printer to kind of get the job done. And each of these components also has its software. And we'll spend a little bit time at the end about open platform and the value of having something like that. And a lot of that gets intertwined in this process, but I want to try to keep it a little bit simple today. And so we'll talk about each step and how the software works through the process. So intraoral scanners, there's all types, there's all models, there's all versions. The scanner that I first got back in 2009 just seems like the dark ages. We had it came with a foot pedal and we stepped on it every time we wanted an image. It was just a challenge to figure out, and we worked through those processes where today's scanners really are pretty cool pieces of equipment. Patients love them. And I think most of the scanners in today's market are pretty accurate. I don't see that there's a whole lot of differences between the scanners that are out there on the market today. In our implant study group, we actually did we kind of reviewed a couple research articles a few years ago talking about accuracy of scanners and definitely, comparing them in the implant world, but it applies to the tooth world as well. And the articles basically said the scanners were reasonably accurate. The only challenge was in the implant world, going full arch scanning had some limitations to the ability to accurately reproduce that data. We've all seen cases in dental journals and magazines where now that's not really an issue. And it's amazing how technology every year updates things, and a lot of that really isn't the hardware, but the software that drives the hardware that we use. So just some common brands, you can see the pictures. In my office currently, we use the Trios 4, and we also have an iTero. The Trios 4 is pretty much our workhorse. One, we live in the 3Shape world, so it's just a little bit easier to communicate. But for us, it's just, kind of being cordless, a little bit easier to kind of get through our daily workflow. We use the iTero for Invisalign cases and also for our backup restorative or planning cases. So whenever, we look at some new equipment, I always try to ask, like, what's our goal with this? What are we going to get out of implementing something new? And a scanner is one of those things where you say, hey, I already do this. There's return on investment and all those things, but the goal is kind of what we already do. It doesn't change. We're taking an impression of teeth. We're taking an impression of a dental arch or some other appliance. But it does make sense. And I think especially after the pandemic, the infection control kind of, got a little bit higher into play. The ability to kind of change the way we practice started to make sense. And it, transitioning from traditional impressions to intraoral scanning really does have a lot of benefits, and more than just infection control, but in a lot of ways, it's an easier way to do things. However, nothing is 100%. There's sometimes I still feel where, hey, an analog impression, if you want to call it that, may have a better option, a better success rate. So the other goal of a scanner is to basically create a digital person. We need to take we're trying to impress and get it into our computer so we can do something with it. And it's that first step in that process is to kind of get that information. One of the cool things that we started doing with our scanner is scanning our adjusted appliances. And so in the digital world, for those of you that have done digital splints, they really do fit well. But I still find, hey, the adjustments are less, but when we go through our equilibration on them, once we're fully equilibrated, even if it was 10 minutes worth of work, wouldn't it be nice to be able to duplicate that? And so at our final equilibration visit for all our splints, we scan that appliance. So not only do we have the one the patient's wearing, but we have the ability to print an exact duplicate of their fully adjusted splint. So sometimes the patients want a backup, if they're going on vacation, they aren't stressed out, they want to take it with them. Or if somebody breaks it, the dog eats it, it's a very easy thing to reproduce at that point. And we actually do the same thing now with all our denture deliveries. After our adjustments, we'll scan the dentures so we have a fully adjusted file that we can utilize. As I mentioned earlier, each hardware has its software that controls what happens. And there's basically two ways that software works with intraoral scanners. Some scanners are impression scanners. They basically capture data. They create a file that will allow us to export that to a lab, export that to a third party, export that to our own modeling software, whatever we choose. But its primary role is just to copy what we want in the mouth. And you set up, hey, we're doing a crown. You set up, we're doing diagnostic scans, whatever it is. You do your scans, and it converts that data into a digital format. The other type of software with scanners is kind of a combination scanner, and this is a little bit like Planmeca and CIRAC, and there's a bunch more, but kind of along the way where, hey, not only can I scan the data, but I can also do some design. And whether it's simple just as model building, whether it's simple, hey, we're doing single tooth dentistry, or in regards to 3Shape or having some other higher version of software, you can kind of create whatever you want in the lab world with digital design from that scan. And so those are basically the two types of software that we have available depending on the scanner that we choose to purchase. So, I always talk about data collection with our scans, and it's a never-ending battle with our staff to always try to obtain more information than we need. You can always eliminate it. There is a limit, as we'll see in a few minutes with our live recording, or not our live recording, but our recorded scan, that we do have to pay attention to how many images we scan, but we want to get more than enough data. We don't want to have to scan somebody and then bring them back because we forgot to scan a tooth, or there was a little margin that we really need and it wasn't visible in our scan. And so every scanner has some way to kind of verify your scan. Looking at these pictures, the top right one is inside 3Shape. It's kind of showing us that, hey, there's something wrong with this scan. And it digs a little deeper into the digital world with artifacts and mesh interferences and all that kind of stuff. But even the Trios, the iTero, they all will highlight areas that aren't acceptable from a data standpoint. The Trios, you can get these little blue marks. They'll show little yellow arrows. The iTero, will circle those items in red so you can go back and scan those little fill holes. One of the neatest things I saw was the Varipulse software. This is that center picture. And so, really quickly, which I love, you're not kind of digging around and searching, kind of scanning like an old traditional analog impression. Green is good. And, the further away you get from green into red, the worse your scan data. And so pretty quickly, it allows you to look at a scan and determine, is this scan data accurate enough for what we need? But it's always nice to have a palette. Sometimes, especially in larger cases, the labs need that to help transfer things. So when we just scan little horseshoes, sometimes we need to figure out a way to get more data. And typically that means, hey, we just got to rescan it. So I always try to get all of our assistants to, scan a full arch, scan more than the teeth that we're looking at, to be able to utilize that data or cut it off. So you're just going to do a quick video of, this is our Trio scanner in action. They're all pretty similar. You kind of set up your patient and you just kind of go through the workflow. As we start this video, every scanner has an ideal path to get the data, but playing with a lot of scanners, I've always found that the technician that's doing the scanning kind of creates their own pathway. And, it may not be the specific design that the manufacturer recommends, but for them it works. And the goal is to get the data with the least amount of scans and have as accurate a scan as possible. And so as we kind of go through this scan, you can see, she's kind of going through, picking up data. kind of switching positions here, just kind of running through and just collecting every ounce of data that we can. And so they'll go through their primary scan, we'll kind of stop, take a look at it, and then decide, hey, do we need to fill some holes? Do we need to eliminate some extra scanning waste products, or some debris that's floating around? You can kind of see that right in the middle of your screen there. One of the neat things is, all of the scanners in today's world have software that really drives the success of our data. The Trios, has their AI scan. You can see that that's on there. So when we click off this scan, it's going to process the data and eliminate most of the debris that was picked up. When we first started, there was a blue glove in there. It will eliminate all those things. Talking about scan images, every scanner has a number that will let them know, hey, you're kind of getting close to having too confusing data that I'm not going to be able to utilize appropriately. And sometimes that AI button will actually start to delete good data because it's trying to balance out, hey, we've scanned too much. And so it's always a good idea to keep an eye on the number of scans that we have, but at the same time, we want to let the technology and let the software help us create better scans. Back in the day, I love that phrase, it makes me feel even older. We used to have to manually go in and clip each little piece of this debris off of our scans before we can go to the next step. Thankfully, today's world, we don't have to do that. So that's the scan, and it's pretty simple. It takes some practice for those of you that haven't done any intraoral scanning. For those of you that have, you learn what's the most comfortable positioning of the monitor, positioning of yourself, positioning of the scanner, all influence how easy we learn this process. And every scanner is a little bit different, but the concepts all apply. So the next piece of our puzzle is really the model building. How do we take this scan and convert it into something we can print? Some of the most common, softwares out there, 3Shape and Exocad are probably the two big guns in the lab world. Dental Wings is another one that's been around a long time. One of the neat ones we were playing with, my associate actually showed it to me, was this Blender for dental. And it started out, the bottom two actually weren't initially dental softwares. And Blender, we're talking about that. It kind of reminds me of Blue Sky Bio, where the software's free or mostly free, and you can design and do all these really cool things, take these scans and start to create files that allow you to print and design stuff, and really, really minimal cost. I believe Blender has a small upfront cost, and then you get to charge basically per export of files. The one on the bottom left, Mesh Mixer, is a great software, totally not meant for the dental world, but it really comes into play when we have scans that maybe aren't the best, that we need to try to clean up without getting a patient back to rescan. When we're kind of in a pinch to get some outside box design, it's a pretty confusing software for most people. I would say my skills in Mesh Mixer are just enough to get the job done, but I know people who are amazing at it and just can create all types of dental products through using it. And so it's a great tool in our toolbox to have to help us kind of get through some of the challenges we may have in the process of going from scan to design to print. So I live in the 3Shape world. It's kind of where I started and kind of am all in on, but some of the things we'll talk about here in a few minutes are based on 3Shape, but I just want to let you know that the workflows are pretty similar through all of these softwares. And the other thing, some of our scanners, we talked about a little bit of overlap with the software. 3Shape has its own model builder, but Trios now, their new version called Trios Unite, sorry, actually has, I believe, some type of limited model building in it. The iTero, after you scan, kind of gets processed and can be generated with some kind of base on there. So I think it's coming where things will be blended more together, but for the most part, we need a separate software to generate our model and create a base. So what's, what happens, so we have software, we get our scan, and that creates, some data, but we need to be able to take this image that's down on the bottom left that has a scan, not really great borders, and turn it into something that we can utilize, in our hands. And so the model builder software will generate the base and also allow us to kind of do things to the models that we need to if we want to trim them up. So say we're doing bleaching trays or we're doing clear aligners. Do we need a palette? No, we can trim that off. If we're doing diagnostics, depending on what level we're doing, can we just trim around the teeth? If we're doing whatever, you have control with the software to determine how much data we want to take to the printer. And so we're going to run through just some of the steps for 3Shapes version of model building. And so, we take our data, we got to import it into the software. Every scanner is different. Every setup in everybody's offices are different. Sometimes it just goes from the scanner right to your software. Other times you have to manually copy and paste, drag and drop, import in, whatever. No matter how that process happens, you need to get those scans into the software. And then we go through the design and build phase, and at the very end, it generates our STL. And so this is 3Shapes order form. We're going to watch this little clip here. So I created our file. Basically, we're looking at building some models. And so as we run through this, we'll import our scans. It'll ask us to import the upper. It'll ask us to import the lower. One of the neat things with digital software is almost always we don't need to scan the byte. However we scan the byte, it's going to bring into the software. So you can kind of see that little preview down below. It had the byte that we scanned. And so if you scan a byte in CR, it's going to come over in CR. If you scan it in MI, it'll come over in MI. So here we're going to clean up these scans, kind of like that one picture with the data collection. We'll see all these little areas that, hey, something's not right. And I've learned through trial and error that the cleaner my scan, the better my design, the less grief I'm going to have. And so I've trained myself every time we bring a scan into software, we're going to make sure it's as clean as possible. And it doesn't mean the margins have to be pretty, but it's from a digital mesh standpoint, we're going to make sure it's clean. And so this is our occlusal plane that we do. And so the purpose in model building is really to kind of create that level occlusion to the tabletop, to the horizon. It's going to allow us to have a level base on there. And so how we set that in, you line it up to the teeth, you line them up to the incisors, and then you click next. And so now the software is kind of generating things. You can see that platform, that occlusal plane that's established there. And so now we can decide how much data do we want in our models. And so we're just going to trim off this excess. For this exercise, we're assuming we just need the teeth and a little bit of gums. So we're going to trim them down kind of low. If we were doing this for where we needed a palette, we would hopefully have a palette scanned. And then we can trim off just the borders of that. And so we do the upper, and then we're going to move to the lower. And kind of the same thing. So we're just kind of clicking around, eliminating some excess data. It allows our models, we can control the height of the models, which we'll talk about in printing, will help determine the speed of what we're trying to print. And so there we generate that. We have our models, and now the software is just going to run through. So one of the options in the software is we can add connections for articulators. And In the non-Dawson world, there's a whole bunch of choices, or non-spear world for you spear folks. Thinking of little additions we can add on. I just randomly picked one. You'll see the models generate. In this case, we can print this connection and just glue our little hinge off the back, so we have a mounted chop model. Like I said, not appropriate for most of us Dawson folks, but an option. And so the software is going to generate, and once we get our final file, it'll give us one last chance to, if we want to trim something, if we need to adjust the model. It's not like we're going to get bubbles and stuff in our models because we didn't take an analog impression. But if there's some gum tissue or we didn't trim our scan enough, we can go back and kind of smooth things out if we chose to do that. And so pretty simply, it took us a couple minutes there. I think it was 3.5, 4 minutes. We were able to take our scan, and now we have a STL file, an object type file that we can send to the printer. And then we can kind of generate our cool digital model. So the third piece of the puzzle, 3D printers. There's all types of printers out there. Most of them kind of started out in the non-dental world and kind of graduated to the dental world. It makes it, makes sense, I think, in dentistry to have some aspect of converting digital to some real object. These are just 5 of pretty common brands that are out there. The very eco, the Asiga, the Formlab, Sprint Ray, Envision Tech, and there's a whole bunch more. I didn't want to get too detailed into talking about differences of printers today. I just really wanted to kind of just get that basic workflow down so we can realize that the process isn't too overwhelming. I have Asiga printers in our lab, and so we'll specifically talk about that workflow, but the workflows are pretty similar for all printers. And so same thing as we talked about, looking at purchasing a scanner, like what's our goal of a 3D printer? Why do we want one? How's it going to affect our practice? Are we going to see a return? All questions that every individual practice, every individual dentist, I think, needs to answer. For me, it just made sense. We were milling objects and thinking of just splints or models, like milling a model out of a solid block of acrylic or some kind of resin takes a long time. And, is it really necessary? What's the efficiency in that? It just didn't make sense to me. And so as printers kind of became more affordable and the technology really kind of picked up, all of a sudden we were in a position where, hey, I think we can utilize this. The downside is we don't buy as much stone. Our model trimmers and vacuum formers and AquaSenses just kind of sit there, a little lonely in the lab, but every now and then we decide to turn them on and make sure they still work and mount some models the old way. But the reality is, with a printer, there's so much we can do in dentistry. But the main goal is to take this design that we just did, as simple as a model, to as extravagant as a PMMA hybrid that we're going to try and or use as an interim restoration. We're going to take that file and create a 3-dimensional manufactured object. Things we do in dentistry, most of us know all this already. Today we're specifically talking about models, but splints are an awesome way to incorporate the technology in our practice. The ability to design and deliver splints very quickly is just awesome. Surgical guys, we use them all the time. Custom trays, every parts of dentures nowadays we're using, and it's just really, really neat to be able to play with some of these materials. And every day it seems like there's some new product that's coming out to help us in the denture realm. And there's also new materials that are considered permanent. I've had some limited experience with them. I've played around with them. I think in certain situations, maybe it's a okay product, but that's where we're headed. And I think more and more we're going to find that there's just going to be better and more improved, more aesthetic, permanent restorations that we'll be able to print out of our printers. So let's talk about the software. Kind of finishing up the third piece of our puzzle. We still need software to drive everything. The printer software will kind of control the printer. It'll kind of work through. Once I have my digital print file, I need to control this hardware to manufacture this. But there's a couple steps in there that we have to follow in order to get our data ready to get sent to the printer. And so, where we place it in the printer, how we attach it to the printer, the materials we choose, the accuracy of the materials, all of those are controlled by the software of the printer. And it may seem like that's a lot, but thankfully, most of this is automated for us. Parts and pieces of a printer, and same thing as before, it can seem like, boy, there's really a lot of things here, but there really aren't. We have the printer itself, the software that drives it. We have the build tray, which is kind of in the middle on the left. That basically holds the resin that we're using. Like I said, I use Asigas, so we'll talk about that. It's in my opinion, one of the easiest ways to and one of the easier printers to swap materials. You clean off your little build platform, which is the middle on the right, put a different resin in there, and you're ready to change whatever you want to print, whether you're going from a guide to a custom tray, a denture base to a denture tooth. It doesn't matter. It's just very easily swappable from a material standpoint. But every printer is going to have this container or vat to hold the resin. Every printer has this platform that is going to allow whatever design we wanted to be attached to and build. So dental printers kind of build layer by layer. And so that platform kind of sits down into that resin. Light will activate and kind of burn onto that metal platform, that first layer. It kind of creates a little secondary layer, and then the next layer gets burned in and then burned in, and kind of just incrementally builds itself up. So of course we have the resins that we use. And then once we get done, that top right corner, you can see a bunch of models stuck to a platform kind of hanging off the printer. We then need to process that resin, because when we first take them out of the printer, there's a lot of drippy, gooey resin that's still kind of lingering around. And we need to get rid of that uncured resin. And so we'll put it in a little wash unit kind of right in the center there. And then we have a couple different curing lights at our, that we need to cure resin. One of my friends, who's pretty into digital dentistry, and he kind of looked at, hey, how do I simplify talking about digital dentistry and 3D printing specifically? And, he said, 3D print resin is really kind of like flowable composite. You have this gooey flowable stuff. We put on something, we cure it, it hardens, and then we do whatever we want to do with it. And it kind of made sense that, hey, it's the same process. We have this liquid, we kind of shape it, do what we want to do with it, and then we need to cure it to kind of finally harden it. And so the curing units, besides making the materials a little bit harder, it actually will help kind of get through any uncured resin that still may be, inside the product that we're doing. So it's a way to kind of get through the process and eliminate excess resin. A big part of printing is how these models get placed onto the printer. Where do they go? Nesting and the supports that kind of hold things together really are dictated by a couple things. One is size of the platform. How many items are we going to squeeze into this print cycle? It's determined by the material, and just about every resin comes with a IFU, which is kind of like instructions to tell us how we should put this on the build tray. It tells us how long we should wash materials, how long we should cure materials. So really important to look at those and kind of get that information into your finishing process. And then there's specific material files that are based on the individual resin, and that will tell the printer, hey, when we make these supports, when we put this object on this platform, how many connectors do we need? What size connectors do we need? Should they be flexible? Should they be rigid? Where do we put them? And sometimes software is great, but sometimes we still need to kind of use our common sense and pay a little bit of attention. And so, when we talk about supports, and I kind of think in the old school, dental school, making sprues for our castable top, items, we want to keep these connectors away from inner surfaces of things. We want to keep them away from important edges. If we're printing a crown, if we're printing dentures, those intimate fit areas, an implant model where we're going to put an analog in, we want to make sure those areas are as perfect as possible. And so we need to keep those supports away from those edges. And lastly, the files, the information files, the materials files will also guide us as to what angle is the best position for our build. It helps with accuracy. It'll control speed. It controls how many supports are put on. And the more supports we add sounds great, but it also means there's more supports we've got to clean off when we're done. So here's just some examples. These are the models that we built for this webinar. On the top left, you can see the yellow models, and then you can see that kind of pinkish purple attachment there. That's how the models get connected to the build tray, which would be that gray box. The next three images are of a surgical guide that we fabricated. And so, part of that material, we want to try to maintain those important areas. And so for a surgical guide, it's really the interface between the opening for the implant and where the metal sleeve is going to attach. And so we want to make sure that we avoid any of these sprues or supports really up close to those specific areas. And then angulation, when we look at where those interfaces are, it's important to kind of make sure that we're not twisting and turning these things where, even accurate printers sometimes can have a hard time completing a build when we put things in a challenging environment without having some kind of support of the resin as it goes layer by layer. And so the bottom line is, it's important to figure out how many items we can fit on a build tray. It looks great on, marketing pamphlets that have like, oh, hey, my build tray has 12 denture bases in it, or 8 splints printed all at once. But sometimes the accuracy of that may not be as good if we just printed them horizontally, or if we printed them at a 30-degree angle instead of vertically. And all of that information can be given to us through that IFU in the materials. And so, and some materials you get what you pay for. There's lots of manufacturers, and sometimes you learn through trial and error that some products just are built better, some are made better, more consistent. So some of the things we print in dentistry, custom trays, models, splints, surgical guides, all components of of dentures, and also those, fancy new materials for crowns. And I think we're getting there with that, but a little bit of ways as a normal everyday type thing to fabricate crowns. So here's the Asiga Max in action. We're going to go through a video here. Basically, we're going to select the material, choose how accurate we want it, selecting our size, import the files, place them on the build tray, and kind of go through the finishing process. So let's go ahead and watch this. So here we are selecting our printer. We're going to select our material. All of these files we've kind of incorporated into our print file. And then we're going to determine how thick we want our layers. And so the smaller, the more accurate, the bigger, the less accurate. So this little rectangle box is really the area that we can build something. The darker gray area is the build platform itself, the bottom of that. And then the box that's outlined is all the space that's available to place our object. And so we're going to import our models. There's the upper and lower model we're going to bring on over. You can copy and paste, you can drag and drop, you can do file import, many ways to kind of get these in. And then we're going to talk about nesting. You know, we can auto place these, we can bring them as they come over. There's a couple different options that the Asiga allows us to do. But as you'll see, sometimes even with the best intentions, things don't always line up. And so anything inside the build area is yellow, which means that's an acceptable position. Anything outside that is pink. And you can see we're still just outside the print area on the top. So we're going to kind of rotate this around and get it to fit. So, you know, one of the decisions is, hey, I have 4 more models to print. Should I stack all these vertically and get them all in one build tray? Should I can do stacks of models, or you know what, hey, I'm just going to do one case at a time or print as many as I can in a horizontal position, because that's probably the most accurate for this situation, and then just do multiple prints. And you know, there's no wrong answer to that. It's just trying to manage how accurate you want things and how quickly you need them. And so the next step is we're going to kind of generate the supports or the attachment to the build plate. And so the software will guide us in that. For models, pretty simple. You know, it just allows us to separate these models off of the platform once it's fabricated a little easier. The video will show you a funny little highlight through that. But it's a connector to the platform. It allows us to kind of help with the adhesion. It allows us to, if these are hollow models, it allows some of the excess resin that's inside to be able to drain. And so it'll also level the models for us. The next part is just working through. We can control whether, you know, we want to change any of the parameters. Most of this, based on the material we choose, is preset. We can really dig deep into some of the features, some of the, you know, if we're having trouble with the resin sticking because it's cold in the basement, we can change the temperature. There's lots of things we can do. Thankfully, most of this we don't ever have to play with. We're going to name our file. We're going to send it to the printer. And then we're going to go ahead and look at every slice that has been created. And it's always good habit to do this. I think, you know, sometimes we may not know exactly what we're looking at, but this is basically the first layer. And we're just going to scroll through as we count, you know, 30, 40, 50, 70. There's 223 layers, I believe, in manufacturing these models. And then we send it to the printer. Our lab's in the basement, so thankfully we can just, through the web browser, open up our front panel and select our models and get them to start printing. And that's it. And it'll, you know, allows you to verify what we're doing. So the final step in the process is getting rid of this excess resin, and we'll see one, you know, video coming up, a little bit of the gooiness that's involved. And, you know, one of the important things is, you know, resins are hazardous. You know, they have odors which we don't want to breathe. They're not kind to our skin. So wearing gloves is important. You know, keeping them off surfaces, keeping them off clothing, keeping them out of your eyes, obviously very important. And so we want to pay attention to how we handle things. Biocompatible resins, you know, resins that we use in the mouth, dentures, splints, surgical guide materials, even some of them have a lot more requirements. You know, some states may require you to enter the lot number. Some states may require you to follow to a T the information for use. You know, if they say, hey, you got to put it at this angle, that's the angle you have to do it at to make it, you know, to meet the requirements of a truly biocompatible material. We're going to take, you know, we remove the objects and supports. We kind of remove excess resin. I like to use a little spray to get started. It just kind of thins some of that excess resin out. Probably overkill, but you know, makes me feel better. We do a 2-step washing. We have kind of a first tank that gets a little bit mucky, and then we have clean alcohol that we finish with. We kind of rotate those. You know, the first phase becomes the old clean one, and then we add clean stuff to the new one. Then we cure, and if it's something that's going in the mouth, we're going to polish it. So here's just a video of the Asiga in action. So it's printed, you can see the models attached. We take the build tray off. You can see some of that shiny resin. We're going to spray it. It just starts to drip a little bit more, kind of running out through the bottom. Got to have some entertainment. I purposely put those tongs there to catch the flying model. Got a little smarter with the second one, stuck my finger on there, but they come off pretty reasonably easy. There's hammers and X-Acto blades we can use. There's paint spatulas. There's all different ways to kind of get these off. Whatever your printer recommends would be the way to go. And then we put the models in the vat. We're just kind of cleaning off excess resin here. Try to be as clean as possible. Before we put it back in the printer, we want to get all this resin off. And for speed's sake, with the video, we kind of just zip through that. I'd probably wipe that a little bit more. But basically, we're ready to go. And after it goes through the 2 water baths in our berry wash, we're ready to put it in our light curing unit. Just a bird's eye view of this second wash of the berry wash. You can see it, really spinning that alcohol around. It really does a great job. When we first started printing, we didn't have these cool, pieces of hardware. And so we used to use beakers and the ultrasonic, and, it just kind of created a mess, and it worked, but it never came out as clean as we get now. Here's the models coming out. You can already see how, they look pretty good. And then once they're dry, we kind of just let them dry. That we use 99% alcohol, so it evaporates pretty quickly. But you can air dry them, and then we'll stick them in our curing unit. And this is a pretty heavy duty curing unit, but it doesn't matter which one we use. You just need to get those resins cured. So we're coming to the end finally. Some final print comments. Clean printers are stress-free printers. I remember Dr. Dawson always talking about, hey, you can tell, the quality of a dentist by their lab work. Resins just magnify that. Plaster kind of washes out, resin doesn't. And so some of the issues that we can have with unsuccessful prints are because we probably weren't as ideal in keeping things as clean and orderly as possible. It's important to dispose of resin and the used alcohol products appropriately. I think every state probably has their ways they would recommend to do that. You don't just want to throw these things down the drain. Cured resin, pretty much I think everywhere you can throw away, but uncured resin you kind of need to get processed. And same thing with the alcohol that's clogged up with all that old resin. Pay attention to the IFUs for each resin. A little bit on open platform. I think, almost all the products that we saw today in the pictures have an open platform. By that, you can use any combination of hardware. It doesn't matter what scanner you use, doesn't matter what software you use, doesn't matter which printer you use. You can take a file and bounce it around between all of them and have a successful outcome. Some of the companies, and kind of thinking back to the original in-office stuff, some of those weren't necessarily open platform. You were limited in what mill you could send something to, what version, what format you were allowed to send stuff to. And if you didn't have software to help you convert those things, you were stuck. And so I think if you're searching for any of these products to implement how you do dentistry, or to improve how you do dentistry, I think it's important to make sure you get an open platform system. To finish up with accuracy, people always talk, I think, and if you read marketing on printers, you're looking at this printer versus that printer, they all say theirs are the best. And to some degree, microns matter, right? It's like crown margins, what's an acceptable cement gap? What's an acceptable limit for whatever? And to some degree, true, but overall, and if we kind of think about broader terms, the smaller the microns, the more accurate your print. If we think of layers being controlled by the size, the thinner the layer, as they stack on them, the less offset there is as we generate each layer. And so it becomes more accurate. The edges are more complete versus having like an old school dot matrix kind of digital like step pattern. The accuracy of our print is controlled, by the thickness. It kind of reverse the verse, right? So the thicker each layer, the less accurate that print's going to be. The number of layers in a print controls the sprint speed. So we saw when we did our slices on those models, that was 223 layers. If we had an object that was 100 layers, it would potentially print half as long. So things that control speed, micron size, how tall something is. Materials also have, time that it takes to cure, to allow it to adhere to the first layer, to the second layer, all the way up to however many layers it is. So those are all factors that will control the speed of an object being printed. For the most, basic concept, I kind of look at two numbers, 50 microns and 100 microns. If something I want printed, I need it to be as accurate as possible. So we think of die models, we think of permanent restorations, implant models where we have an analog that's going to be inserted into that model. Those all get printed at 50 microns. It's pretty much as accurate as we need in dentistry. Everything else I print in 100 micron level. So study models, splints, dentures, custom trays, massage tracers, anything else we do, pretty much for speed, because, the accuracy is good enough for those types of applications. That's it, we're done. So pretty straightforward, how we scan, how we get to the final model, a lot of conversation in the middle of that, but the basic concepts, you start with a good scan, you use software to generate the model and the base, and you get it sent to the printer and clean up your model, and there we are. And so I want to thank everybody for hanging in there with me. We're just under an hour, so they wanted me to talk for an hour, so I'm pretty happy with that. I want to thank Whitmix, the Bear One team. Thanks for helping kind of put this together, and thanks to everybody.
Awesome. Well, thank you, Dr. Wahl. It's always good talking to you. I don't see any questions, which means you did an excellent job explaining everything. So, a couple notes before we do close. So for all of the attendees, you're going to see a poll pop up on your screen. It's just going to ask you if you would like to be contacted by a Whitmix rep. Feel free to choose either option. If you choose yes, one of our sales reps will be contacting you to talk to you about any questions you might have had. Also, just a quick reminder, just to reiterate, this webinar was recorded, so you can go back and watch it on our website anytime you'd like, and it's also available on our Facebook page. And again, keep an eye out for the email about your CE credit if you need that. And with that, once again, thank you, Dr. Wahl. This was super informative, and I'm really glad we got to talk to you today. So thank you very much.
Awesome. Thanks, everybody. Yep. Thanks, Bryce.
All right. Bye, everyone.